Hello and welcome to the BMC Learning Series. Today we'll be covering MainView SRM Allocation, Part 1. In this three-part series, we will explore what allocation is and its benefits, its functions, SMF reporting, and allocation analysis. MainView SRM Allocation provides automated actions to prevent out-of-space conditions for both SMS and non-SMS datasets. With the automated actions, allocation prevents reruns of jobs and manual interventions to resolve incorrect JCL coding of space values. The net result? DASD usage is allocated more efficiently, and tight batch windows are relieved along with the handling peak workloads without interruptions. DASD space problems are caused by a variety of conditions. No secondary coded or coded incorrectly, allocating duplicate datasets, datasets that have been allocated without an end-of-file marker, over-allocated datasets, and many other contributors. MainView SRM Allocation responds to all of the previous DASD space error conditions by providing a single point of control for everything related to dataset allocation. This includes redirecting dataset allocations to better fitting volumes, both SMS and non-SMS, organizing tape drives into pools, enforcing dataset name and allocation standards, to name a few. MainView SRM Allocation operates at the operating system level, so there's no need to alter any JCL or make other changes to batch jobs. So let's take a look at the functions within the allocation solution. There are functions to pool datasets, enforce data center standards, enhance tape functionality, and enhance DF SMS functionality. There are also functions to enhance dataset allocation efficiency, enhance volume selection, and of course functions to provide space recovery actions. As noted, there are functions to proactively correct space problems. These functions are invoked because of an error condition or some event during the allocation process. SPAC Valet and SPAC SWIR are related to volume switching, or the addition of volume to dataset allocation. This is for non-SMS and SMS managed datasets. The limit is 59 volumes, and this is just the ZOS operating system limit. Functions that are directly related to correcting space during allocation, or while a dataset is extending, are SPAC Prime, SPAS Quantity, SPAC Sec A, SPAC Sec B, SPAC Sec I, SPAC Sec R, and SPAC A Quantity. SPAC A Quantity is a unique function that requires allocation, reporting, and automation to be licensed in order to use this. This function can automatically adjust the user's requested primary or secondary requests based on past allocation metrics so that the data is always allocated correctly, thereby removing the need to use DF-HSM or other services to release space. Additional functions that assist in correcting out-of-space conditions are Open EMPT, Opt Block Size, SPAC Conv, SPAC RLSE, and VioAlloc. These functions are used to optimize the allocations by changing the allocation requests at allocation time. These functions are not invoked as part of intercepting an error condition, or even during the allocation process. These functions make hard changes at allocation invocation. An excellent example is SPAC RLSE. This slide illustrates some of the selection criteria that can be used in the SRM FLST or RLST members. Pattern masking follows the standard IBM ISPF masking, with the exception of the slash. When the slash is used, all information beyond the slash is ignored, and the mask is in effect for anything to the left of the slash. As we discussed earlier, the SM-Func member determines which functions will be active, and which FLST and RLST will be used for that function. The same SMF list member can be shared by multiple functions. The SMR list member cannot be shared among functions. Items that are set as mode equals enact will generate a message from the SVOS subsystem with the following syntax if a recovery action was needed. SVW 4001I recovery attempt failed to pass FList RList job name. If you do not require to exclude or enact anything, do not. You may prevent this message from appearing by changing the MSG equal parameter to E instead of I. Rule lists determine what type of actions are to take place. For example, how many volumes to add to a data set, or what data set to archive because of an exceeded threshold condition. Not all functions require an RList member. When coding an include or exclude statement, if several items are in the same line, then all volumes must be matched for the condition to be true. These are considered AND statements, not OR statements. When multiple INC statements are used for the same set statement, then these are considered OR statements, and any statements could be true for it to be a match. Once a resource is matched, the code is exited. For this reason, you should code specific to general and put exclude statements before include statements. The FLists and the RLists are read from top to bottom. SRM always uses a set statement to begin processing of any keywords and parameters. If a set statement is not coded, the include or the exclude statement will be used as part of the prior set statement. If no include or exclude statement is coded, the set statement is ignored. We discussed the sharing of FLists earlier, and that RLists cannot be shared. You should use caution when sharing FList, as resources could be used for that function that would not normally be used. A good example is DB2 table spaces, as they can be used in SPAC valet function, but not many others. The example shown is for function SPAC valet. The FList is active and all datasets are eligible for consideration. The RList sets the volume count to 20 and also tells SRM to bypass the note processing and allow these datasets to be included. By default, SRM does not allow for volume adds for note, point, or EXCP processed datasets. We will exclude datasets starting with PDB and DFHSM. We'll also exclude any datasets that have an LLQ of CSI. We could have used exclude LLQ equals CSI, for instance. The datasets that will be allowed to expand to 20 volumes include the following. Any dataset starting with rxf.out file. Any dataset starting with CSG that is a VSAM dataset and is also in a job starting with rdgmis. Any datasets with a second qualifier beginning with pay. Any datasets that are executed using the program beginning with RAFPR. Another example, we will not include any datasets that start with RDG and are of a size less than 50 kbs. All other datasets are eligible. The other set statement rejects store class that begins with sys, temp, or test. Datasets that start with pay, rom, or rec will get allocated to the tape pool. Datasets beginning with RDG, CST, or BMC will depend on if VT90 is assigned. Let's look at some of the allocation functions. NoCatalogG2 is a function that prevents JCL errors for duplicate SMS datasets and NoCat2 conditions for non-SMS datasets. There are several ways that SRM can recover the error condition. We will look at these methods. For the RList member of NoCatG2 function, there are several set statements that can be coded to provide various levels of recovery, depending on whether the dataset is SMS managed or not. The options are to fail, rename, delete, uncatalog, cancel, flush, opper, or take no action. The no-cat-when statement is used to determine when the function is to be invoked. SMS is at allocation time, and non-SMS is at step end. The purge keyword can be used should the existing dataset have an expiration date and the user is wishing to delete the dataset. An event ID can be coded if an event is to be created for notification purposes. Remember, the MSG and SMF params associated with the function will display the action. The no-cat G2 function is one of the few functions that provides global system parameters that are used during recovery actions. Some have default values, which are fine to use as is, while others do not and must have something coded in order for the function to work properly for the actions requested. The no-cat PFX is the 1 to 3 character second qualifier that will be used when the rename option is used on the rlist set statement. The default is BAB. No-cat SMS must be set to yes if the function is to successfully rename, uncatalog, or scratch an SMS managed dataset. No-cat time can be used to extend the time frame of the recovery. Very useful if the system is very busy. No-cat vol determines if the same volume or a different volume should be used for the uncat, recat of a dataset. The other params were discussed in the rlist param slide. The rlist params can override any global setting. An example of the no-cat G2 function. The SM-funcNN member of the no-cat G2 function is set to active equals yes, which turns the function on to the system. We have all the messages displayed and SMF will capture everything. Note that the flist member suffix is 00. The rlist suffix is 08. The flist is set mode equal to active, and all datasets are selected for consideration. In the rlist, the first action is to fail all jobs for TSO users who attempt to allocate a duplicate dataset. The next set statement is to delete with a purge all duplicate datasets in batch jobs with a job class of T. The next set statement is to rename the duplicate datasets in jobs with a job class of P. The last set statement is to just uncatalog all duplicate datasets. Okay, the next function we'll examine is the openEMPT function. This function is very useful in preventing wasted space because of datasets that get allocated yet do not get an end-of-file marker. The result is an undefined DSORG dataset, and DF-HSM cannot process these types of files, and neither can the SRM function SPAC RLSE. Using openEMPT prevents the occurrence and closes the dataset properly. Datasets are automatically excluded from the openEMPT function if the disposition is delete, the dataset is a PDS, or the dataset is a VIO. Some functions do not have an rlist. In other words, there's only one action to take. Everything is based on the flist, so whatever resources you wish to have an action taken, just include the resources in the flist member, and the function will process the function's intended actions. openEMPT is a function that fits this criteria. You either have the function close the file properly or you do not. The function also does not have any global system params. The message ID will be one of two messages, SVM0500I if successful, or SVM0501I if unsuccessful. An example of coding the openEMPT function. Again, we have all messages and the complete SMF collection, and the flist suffix is 03. We have defined variables in the SM vars member, one for test PGMS and one for test jobs. Because the openEMPT does not require an rlist, we only have to code the resources to be considered in our flist. The filter is active for all programs defined in our test PGMS variable, and also any job classes that are contained in our test jobs variable. The PDS-DIRAD function can dynamically add directory blocks to regular PDS datasets. There are limitations because of the process required to add directory blocks. The STO interface from IBM is how directory blocks are added. Within the R list, you can have the option to bypass the ENQ. Care should be taken if bypassing the ENQ for some libraries, as the TTR entries will change, possibly disrupting some online processes. As with most other allocation messages, the SVM 4000I message is displayed first, which states the attempted action. For the PDS DIRAD, there will be one of two messages that follow, one if successful, one if unsuccessful. An example of the PDS DIRAD function. All jobs considered for the recovery action are in the F list. However, in the R list, only jobs that start with prod will be recovered, and only if there's no ENQ on the dataset. The default is no, yet for documentation purposes, we code the parameter. The SMS select function is useful to enhance allocation of DF SMS managed datasets. DASD pool has been used for many years to pool non-SMS datasets, and SMS select provides similar allocation benefits in assisting DF SMS to maximize the defined storage groups. Since both functions work in similar fashion, the keywords for use in each function are identical. In addition, just like DASD pool, SMS select can allocate datasets based on performance metrics, along with the logical volume statistics of capacity used. There are a few global params that are used for SMS select. These params are related to the actions that SMS select can perform and are not required for the SMS select function to be used. CritList is used to identify the member that will be used for critical dataset placement by SMS select. HistDays is the param to determine the number of days to use for using performance data when placing datasets based on performance statistics. If the param is not coded, then the default is 0 days used, and no data is stored in the data space that is created. SMS alloc and SMS extend are required if the SMS select is used with subpooling. In all, there are 30 different params that can be used in the R list of the SMS select. For this session, we concentrate on one of the more common params, volcel. Best fit, max space, and percent are used by the function to allocate datasets to logical volumes based on the requested space of the allocation. Best fit will select the volume with the smallest contiguous extent. The thinking is that volumes with small segments of contiguous space will get used for small allocations to prevent fragmentation. Max space is used for large datasets, again using the large contiguous chunks of space based on space requested. Percent selects the volume with the largest percentage of free space. DPO stands for DASD Performance Optimization. When used with volcel, you can allocate datasets based on volume performance. DPO is based on real-time performance statistics. If DPO is selected, and it works with the CritList, SRM Allocation looks at the other DPO params to determine placement of the datasets based on DASD response times. The historical DASD Performance Optimization param for the SMS select set statement is HistDPO. When using HistDPO, then HistDays in the SMM sysxx member should be set to something other than the default value of 0, so that the historical data is collected and retained in the data space. Values can be set for maximum and minimum response times, a range of snapshots, which are the SMF, CMF, RMF intervals, or even days of the week can be selected in order to provide granular settings for the most critical times for optimum performance. Here's an example of using the SMS select R list for using the volcel parameter with best fit, percent, and max space. That concludes part 1 of this series. For more videos on MainView and other BMC solutions, please visit our BMC mainframe YouTube channel at youtube.com/user/BMC software mainframe/featured. That's it for this session. Thank you and see you next time.